Hey everyone, my name is Jose, aka Joe Engineer, and today I'm going to show you how to measure the fuel pressures on an old air-cooled 911 running Bosch CIS fuel injection. Thank you once again for joining me. So today we're going to learn how to measure a few of the important fuel pressures that one needs to know to make sure that your air-cooled Porsche 911 running CIS fuel injection is running correctly. This applies to any old 911 that's running CIS, 1973 through 1983 for the NA cars. It also applies to the 930s, the turbos, as well as I want to say some of the 964s as well that run the CIS fuel injection, but I'm going to focus on the NA cars because I am not familiar with the way the turbo cars are set up. So yeah, let's keep this NA focused video for now, as the systems are fairly similar. So the main reason why the fuel pressures need to be measured on your CIS system is that, as we had discussed previously in a prior video, the CIS fuel injection is very mechanical in nature, very temperamental, and so everything needs to be set up fairly correctly in order for it to run. Otherwise it'll not run very well or cause other issues. We had previously covered a video on how to check for vacuum leaks in common areas where vacuum leaks can occur. Here we will be checking the fuel pressures, and in general, if you've eliminated all of the vacuum leaks in the system and verified that your fuel pressures are where they need to be, then you've eliminated the great majority of drivability issues that occur with CIS. There are other little electrical problems and other things here and there that happen, but they're far less common than vacuum leaks and fuel pressure issues. So I'm going to show you how to measure essentially four major fuel pressures: the system pressure, the control pressure while it's cold and while it's warm, as well as the residual pressure, and I'll explain those in a little bit more detail later on. So the main in order to keep this as basic as possible and not lose everyone, because there are many different subtopics that we can cover with CIS. The system pressure is the pressure coming out of the fuel distributor going to all of the fuel injectors. And that pressure, as you know, varies up and down depending, is controlled by the flapper valve that's inside the airflow meter. And the more air the engine inhales, the more fuel the fuel distributor will send to the injectors to keep the air-fuel ratio as good as possible. So the system pressure is the pressure that is going to all of the injectors. The control pressure is the pressure that is controlled by something called the warm-up regulator, which is a little device buried over here and is responsible for making sure that your car will cold start and warm start correctly. It also keeps working while the entire time that the car is running, but its main primary function is to produce a certain cold control pressure when you first start the car, when the engine is stone cold, and then ramp that pressure to a warm control pressure that is ideal when the engine is warm. That way, in an ideal case, if the warm-up regulator is working correctly, then you should be able to cold start your car with 0 issues and take off driving. And you should also be able to warm start your car and immediately take off. No waiting for, you know, the car to warm up with your foot on the gas or whatnot. The last pressure that we need to measure will be the residual pressure, and that is the pressure that is left in the system after you shut the engine off. There are a couple of devices in the fuel system that keep the fuel lines pressurized to a certain extent to prevent vapor lock, and also to allow the engine to start up as quickly as possible again with no sputtering or you know, difficulty. So we're going to measure those 4 pressures. Some of the basic tools that we need are you will need a fuel injection pressure test gauge set, just like this one. This one, I don't remember where I bought this, but it wasn't on Amazon. I think it was a specialty tool website of some sort. I will dig it up and I will put the link in the description once the video is published. This one is by S&G Tool. Part number is 33800. And it is specifically set up for Bosch CIS K-Jet systems, which this is what it is. To give you a quick overview of what this looks like, is you can actually make one of these with an existing pressure tester or with kind of off-the-shelf components. It is simply a pressure gauge that measures fuel pressure in PSI and bar. It's got a little relief valve here, a section of fuel hose connected to a T, and then on the end of the T are 2 more sections. Just one straight section, and another section that has a little on-off valve here that we'll see in a bit how this connects. But that's really all you need. And then it came with a bunch of various brass fuel fittings so that you can adapt it to whichever car you are going to use this tester on. This one came with this is a pretty old tool. If you look at the instructions, it has instructions for how to test the pressures on Porsches, old Volkswagens, BMWs, Volvos, and a few other European cars that use this fuel system during the I guess kind of 70s and 80s and maybe early 90s. But anyway, yeah, this there are other types of gauges out there. I've seen people use Harbor Freight ones and you know, some of the other local auto parts store gauge sets. Up to you. In reading in the forums, I was told that this was the kind of the good one to get, the reliable one. So I took some time to search for it and find the right one and buy it. I think they're a little bit hard to find occasionally, but if you check on eBay or various tool websites for this S&G Tool number 33800, it should come up. And I've had this set for many years now, and it's served me very, very well. So in addition to this pressure test gauge fuel test pressure set, you will also need a pair of wrenches to connect the tester to the fuel lines. I'll show you in a bit where those go. And on mine, we will be using 2 14mm wrenches. So yeah, just typical open-ended wrenches. You will also need a rag or a paper towel, because remember, there is fuel pressure in the lines right now. So when you crack open one of the fittings, a little bit of fuel might spray out, and you want to just cover it up and prevent it from spraying as you do that. You will also need a little jumper for the fuel pump relay. So when you run this test, you have to do it with the fuel pump running but the engine off. So in order to trick the fuel pump into doing that with the ignition open, you have to remove the fuel pump relay, and you need to jump 2 of the terminals for the fuel pump relay in order to get it to operate. And this one is literally just two bullet terminals that fit into the fuel pump relay, and it has a fuse on it. Some people like to put a toggle switch, but I personally don't have the need for the toggle switch, because I'm going to go halfway between here and the fuel pump relay is the ignition, and I would rather just turn the key and to make this thing work, rather than go all the way over there and hit a toggle switch. So not much here, not much going on here, just a piece of wire, 2 terminals, and a fuse. I'll show you how to connect this in a bit. You will also need a piece of paper and a pencil to write down your fuel pressures as you go along. You will also be timing them just for reference. So a timer, a clock of some kind will help you out. You should also know what the temperature is in the area where you will be conducting the test. So either look it up online on your phone, or if you have a thermometer, then look it up there as well. And lastly, after you have collected all of this test data, you will need a manual of some kind so that you can cross-reference your data, your fuel pressures data, and see if they are within spec. And because my car is a 1983, this is the Bentley manual that corresponds to my car. And this one, at least the SC one, 78 to 83, this one is actually surprisingly good for as far as CIS detail. It has pretty good written test procedures on how to conduct the tests, and it also has a lot of good tables to show you the criteria, the acceptance criteria for each of the tests. So yeah, make sure you get one of these. You can also look it up online, but I like to have a paper copy as well. So make sure you grab one for whatever model you are working with. A few warnings before we begin. We will be working around fuel, and there is a potential for some fuel to spill. So make sure you're working in an area with plenty of ventilation, no sources of open flame or spark. Keep a extinguisher nearby if possible. Perform at your own risk, but be safe. Okay, so first things first, we need to do a little bit of preparation here. Get yourself a zip tie and loop it under your tailgate deck lid so that you can take your gauge and hang it conveniently and read your pressures as you conduct the test. This one's been here since about 2020, so yeah, I just keep it there. Secondly, find your warm-up regulator, which is this little device back here. So let me zoom out first. In your engine compartment on the left-hand side, kind of in between the intake runners, you'll have this sort of rectangular looking little box right here. And it has, some may have a vacuum line, some may not. you will have a couple of fuel lines in here. One will go to the back somewhere, and another one is going to go, follow the fuel line, it will go back. The filter cover here is obscuring it, but it will go here, turn into this hard line, which will then go to the fuel distributor right there. That's the line that we're going to tap into to read our fuel pressures. All the other lines that you see on top go to the individual injectors, but we want this guy here coming out this way and going to the warm-up regulator. Also, you will need to disconnect a couple of things. Depending on the year of your vehicle, if yours has a vacuum line or not, this is more of a vent and less than it's not really connected to vacuum. On some, you may have to disconnect the vacuum line to do the test. It depends on your year. Check in the manual. On mine, I don't. But you will need to disconnect this electric connector here. And also, to be safe, because we will be running the fuel pump without the with the engine off, go to your CDI box and disconnect the big connector that is underneath it. It's a big rectangular connector with a rubber boot on it. You can't really see it, but it's the only one down here. Ignore this. This is some other aftermarket stuff that does not apply, should not apply to anyone else's cars. But disconnect this boot electrical connector from the bottom, and this, and we will tap in here for our fuel line connections. Grab a tiny screwdriver and very gently release the electrical connector from the top of the warm-up regulator. Be careful not to break anything or bend anything on the connector itself. Once you have it released, just put it off to the side. Then move on to the CDI box connector. You may need to wiggle it quite a bit to get it out, but it'll come out. It's a big rectangular white connector like the one shown. Then grab your 2 wrenches and your rag or your paper towel. Hold the fitting at the bottom of the warm-up regulator and turn the fuel fitting on the fuel line itself on top to loosen it, and then you can gently spin it off and be very careful of any fuel that may spray at this point. Then grab the fuel pressure tester and connect the end that does not have the valve to the other end of the line. Grab your 2 wrenches and very gently tighten them using hand pressure only. Don't go too aggressive on these so you don't damage them. Then take the other end of the fuel pressure tester and the line that has the valve on it, the shutoff valve, and connect that to the top of the warm-up regulator. And once again, hold the fitting on the top of the warm-up regulator, and with the other wrench, spin the fitting on the top of the fuel hose and very gently hand tight the fuel line on. And that's it. Make sure they're oriented as shown with the valve towards the warm-up regulator. Shut the valve off and you're done. Over here at the front of the car, take your jumper, go to your fuse box, remove the cover, and the fuel pump relay is the big red one right here. If someone has swapped yours out with a black one or something else, confirm on the inside of the fuse panel cover here and make sure that it is the correct one. For me, it's this red one. So remove it, and underneath the relay, each pin is identified with a number, and we will be connecting pins 87A and 30 together. So if you look at, there's 87A and there's 30 right across from each other, this guy and this guy. So match those up with the socket and make sure that you pick the correct terminals in here with your jumper. Here's the jumper and the correct terminals. And keep in mind that here all I did was take some off-the-shelf bullet style male connectors that you can get at any auto parts store. And with some pliers, I was able to kind of smush them down into roughly the diameter of these the pins on the fuel pump relay, and they fit in pretty snugly. So once you've got that connection, you can go back to the front of the car. The rear of the car. Okay, we're ready to begin the test. Remember, car must be stone cold, preferably left overnight. Your warm-up regulator electrical connector must be disconnected for the first part of this test. Otherwise, everything else is hooked up. Now I'm going to go turn the key on the ignition to on, and we should hear the fuel pump run. Pump is running. Pressure went up. I'm told you're supposed to take the gauge, turn it upside down, and open and close the valve a few times to purge any air that may be inside of the gauge. So let's do that real quick. Closing the valve again, connecting the gauge. I'm not sure if you'll be able to read the reading from here or from your viewpoint, but I will tell you what the readings are as I record them. So this is our system pressure. I've got 4.7 bar. 4.7 bar system pressure. So I'm going to write that down. System pressure 4.7 bar. Now we're going to open the valve and measure the cold control pressure. Valve open. Pressure has dropped to have 1 bar. Remember to record the temperature at this time, because the temperature of the warm-up regulator has a direct effect on what this cold control pressure is going to start at. 1 bar. Now get your timer ready, and we're recording time just so that we're not sitting here for an hour waiting for this to keep going and going. I think we're going to wait about a 10-minute period in order for the pressures to climb. It's more of a reference measurement so that next time you do the test, you know how long you need to wait. But anyway, get your timer ready. Start the time. Connect the electrical connector on. and check it maybe every couple of minutes. So now with the electrical connector connected, there's a heating element inside of the warm-up regulator that is gonna start to warm up with the current, and it'll start to change its shape. And when it changes its shape, the pressure will start to climb. You can see the gauge already moving. So I've got, okay, at 1 minute, I'm already at 1.6 bar. Okay, 2 minute mark, 2.2 bar. Looks like it's slowing down now. Now approaching the 3 minute mark. We've got 2.8 bar. 4 minute mark, we're at 3 bar. 5 minute mark, 3.1 bar. 6 minute mark, not quite 3.2 bar, like 3.15. 7 minute mark, 3.2 bar. If we were plotting pressure over time, you would see the pressure start to taper off. 8 minute mark, still at 3.2 bar. 9 minute mark, 3.25 bar. I'm gonna stop it at the 10 minute mark. Okay, 10 minute mark. 3.25 bar, hasn't moved. Okay, we're done. So that's it. This is the warm control pressure. Okay, so now you should have data for the system pressure, the cold control pressure, the warm control pressure, and now we're going to test the residual pressure. Essentially, we're going to be measuring the pressure that stays in the system and how quickly it leaks down through various components in the system. So in order to remove the warm-up regulator from this test, close the valve. Which should give us our system pressure again. And now turn the ignition off so that the pump shuts down. And once again, start the timer right now. So, residual pressure at 0 time, or at time equals 0, initial timing, 2.8 bar. So, the Bentley manual for my car lists what the residual pressure should be after 10 minutes of sitting, after 10 minutes of shutting off the fuel pump, and after 30 minutes. So I'll come back and record this pressure after 10 minutes of sitting and after 30 minutes of sitting. So at the 10-minute mark, the residual pressure has dropped down to about 1.8 bar. So after 30 minutes, my residual pressure has dropped to, what is that? 1.5 bar. So after recording your residual pressures, we need to bleed the pressure out of the line. Let's see, let's open this, see if this works. Open this. So now we've got the same pressure through here. Let's see if this little check valve will relieve the pressure. Might leak some fuel. Or, nope. Oh, does it? Yeah. Yep, I'm holding it down and it's bleeding a little bit of fuel. Yep. Okay. I think if I crack open the fuel line now, it should be less likely to squirt fuel. Okay, not to get too much into the weeds, but let's review the data really quickly just to see how we did. So, to summarize, the system pressure that we measured was 4.7 bar. For the Bentley, the system pressure, engine off, pump running, 4.5 to 5.2 bar. So it looks like we're okay. We are at 4.7 bar. Good. Cold control pressure, 1 bar. Warm control pressure, 3.25 bar. That's based on this. So remember, we were recording it, the pressure versus time, only because I wanted to get an idea of how long it takes for the pressure to taper off. And I got up to about 12 minutes. It doesn't, past the 9-minute mark, it doesn't change much. I got 9 minutes, 3.25, 10 minutes, 3.25, and same thing at 12. So next time I repeat the test, I'm only going to run it for about this much time. I'm not going to sit there for 30 minutes waiting for something different to happen. So there's that. Now, if we look at the Bentley, so the Bentley has different plots of temperature versus pressure depending on the model year. And that is because different warm-up regulators have different pressure curves. So I forgot to mention that earlier, but make sure that your warm-up regulator is the correct one for your model year and engine. Each warm-up regulator has a part number on it. Usually you could tell it apart by the last 3 digits. For example, 045, 069. Mine is I think it's an 090. Yeah, 81 to 83, 090. Okay, so make sure you have the correct warm-up regulator. Look up the part number directly on the casing so that you're looking at the right table, and hopefully that should reconcile with your test data. So, control pressure specifications, engine cold. Well, it says and running, but I believe we can still read this with the engine not running. Engine cold, engine warm. Engine cold, see graph. Engine warm is this. So engine cold. Today, we measured at a temperature of 62 degrees Fahrenheit where I am. The cold control pressure was 1 bar. 62 degrees Fahrenheit. Oh man, we got to convert to Celsius. So today, our temperature was 62 degrees Fahrenheit, which is 16.6 degrees Celsius. So we are looking at 10, I'm guessing 12, 14, 16, 18, 20. So 12, 14, 16, right in there. I got 1 bar. Mine is a bit low. Actually, it's way low according to this plot. Yeah. And the warm pressure is 3.4 to 3.8 bar. And we've got essentially 3.3 bar if we round to 1 decimal place. So don't get too caught up in my data, because this this is the result that my warm-up regulator has given me ever since I had it rebuilt. And mine was custom set up by a gentleman I know, and he set it up for me. It runs beautifully, cold start, warm start, winter, summer, doesn't matter. But your data should reconcile with whatever is in the Bentley. Now, moving on to the residual pressure. I believe that was back. Where did I see that? Residual pressure. So residual pressure after 10 minutes should be 1.3 bar minimum. I had 1.8 bar. After 30 minutes, 1.1 bar minimum. And I have 1.5 bar. So that tells me that I don't have any fuel leaking past devices that it shouldn't be leaking past, such as the injectors or the check valve at the pump outlet, or the what's it called, the accumulator, which maintains pressure in the system. So that's good. So my cold control and warm control pressures are a little bit off, but this is a known condition that I am aware of on my car, and it runs just fine. So disregard the validity of this data, but your data on a stock warm-up regulator, unmodified, etc., should line up with these charts and the data in the Bentley. So that's all the analysis that we're going to go through right now. We can deep dive into any one of these and go down the rabbit hole and really start to lose people, but we won't. This is all we're going to cover for now. If you know how to run these tests and get this data, then you can very quickly pinpoint problem areas in your fuel system to then determine next steps for troubleshooting. So that is pretty much it for the process on how to measure your fuel pressures on CIS. There are other things you can do. You can, the way this is all hooked up, you can technically, if everything is secured, if you've got the hoses and the gauge secured, you can technically go drive around with this, get the engine up to temperature, and do test some of these, test the residual pressure or test the warm control temperature with the engine hot, in case you have any hot start issues, or just want to see how having a hot engine affects the way some of those pressures drop. In order to return everything back to normal, I'll spare you watching me disconnect everything. It's the reverse of what we just did. You remove the jumper from the fuel pump relay socket, you reconnect the fuel pump relay, disconnect this gauge setup from the, actually it'd be better if you disconnect it from here, the line going to the fuel distributor. When you crack this open, this is still pressurized and it might squirt out some gas, so put a rag or a paper towel over this before you do it. Reconnect the fuel line to the distributor back to the warm-up regulator. The electrical connector is already in. Reconnect your CDI, and you should be back on the road again. Thank you so much for watching. I know this has been kind of a dry topic, but it's just one of those things that is so important for CIS in order to operate correctly, and most people overlook it because it's boring and it's very confusing. the way it's explained in most of the literature. So I've tried to distill it so that hopefully if you follow these steps, you can collect the data and then go back to your manual and cross-reference what those pressures are supposed to be in order to start any troubleshooting that you may need to do with any running issues. But yeah, that's about it. I'll try to cover more CIS topics in the future just to clarify more CIS mysteries, and remember to please like and subscribe, and I'll see you in the next video. Thank you very much. Bye-bye.